Hello and welcome back to Module 2. In this module, we're going to start off by learning a little bit about DSC. Now, I promised you in the last module that we were going to spend a lot of time discovering what DSC means in concept and then working our way through implementation in Azure Automation using DSC. So back here to deliver on that promise. Um, this is a concept video. I'm going to spend 5-10 minutes with you talking about DSC, why it's required, what are its benefits, and what is the real problem that DSC solves that has traditionally always been a gap. No great concept video is complete without a story of evolution, and evolution it is. Well, we started with Windows NT, which kind of felt like the server for masses era, where servers were being created to reach the broader audience. There wasn't really any automation. The only way to automate anything was writing some VBS or some DOS-based batch files. From that era, we promoted ourselves into an enterprise era where PowerShell got introduced into the mix, and you could do some level of automation by scripting using PowerShell to create a solution that would do something and then quickly do that activity across multiple servers. You still didn't really have the concepts of remoting in place, so you still had to manage your data center yourself. Then with the invents of Windows Server 2008 and Windows Server 2012, really came the era of data centers, where PowerShell had reached a certain level of maturity. You could use PowerShell to remotely administer servers, and you really had the power of commandlets and modules. And it was also the introduction of desired state configuration. What this era really allowed you to do is use PowerShell for automation, but meaningful structured automation. And because PowerShell had reached a level of maturity, it got a huge ecosystem around it, an ecosystem which was vibrant, not open source yet though. Um, and the era that we're in now, the era of Windows Server 2016 and Nano Server, is the cloud era. The PowerShell is absolutely ready for it, and it's ready, built ground up again, uh, keeping DevOps at the center of it. With PowerShell today, you have desired state configuration. You have a testing framework called Pester, which allows you to unit test your PowerShell scripts. You have an inbuilt package manager, so no more do you have to go and hunt for modules that you need to install. It just offers that capability right from within the console. You've got code analysis using Script Analyzer. You've got support with Visual Studio Code, which means you can write PowerShell backed by Git repositories, unit test them, CI them, CD them. PowerShell have classes as well now, so you could do your structured programming against them. PowerShell now also has security, which is referred to as JEE, just enough administration, and it's improved audit logs as well. You've got a PowerShell gallery, massive gallery, open source support, and cross-platform support. Now, cross-platform support is huge. You could run your PowerShell scripts not only on Windows, but on Mac and Linux as well. Kind of feels that PowerShell is ready. It's gone through its evolution, and it's ready for prime time. So PowerShell is has been in play for a very long time, and as the PowerShell framework itself has evolved, the style of writing PowerShell has had to evolve along with it. And because the OS has evolved as well, if you bring the three together, you're kind of heading in a great space there. Now the screen on the left side has an imperative syntax, and the one on the right has a declarative syntax. The imperative syntax is, if you look at it, kind of assuming an early state of where the script is running, as in the base state, and then the script is really building on top from there. So if the base changes, the script is bound to fail. So for example, we are checking whether ASP.NET, we're checking whether the web server feature is enabled or not. And then if it's not enabled, then go and install it. But if it's enabled, then don't install it. Then you have to manage your try-catch block. So what if the execution fails? You kind of need to handle it within your catch block. If you run the script again, is it going to perform in a consistent way? Maybe, maybe not. For example, at the bottom there, you're creating a website. If it already exists, how is the script going to handle it? becomes very tedious to manage implementation or automation in this syntax. On the right side is the declarative syntax, where you're leveraging the capabilities of the OS. Rather than script what you want, you tell the OS what you need. And the OS is capable of looking at the current state of the OS and working out what it would take to get to the desired state. And in the process of that, behind the scenes, it creates the imperative script that it needs in order to bridge that gap. For example, I'm demanding that there is IIS set up. I'm demanding that ASP.NET is set up. I'm demanding that a website exists there. So if the website already exists there, then the OS just verifies that it exists and has the same variables that I've called out here. If any of these variables are missing, it will bridge the gap by creating the imperative script to perform that action. And the OS is able to do it because the OS has what's called a LCM. And LCM is a local configuration manager, which takes the instructions and does the heavy lifting behind the scenes to bridge that gap. No surprise, the syntax on the left is helping us arrive at what I called earlier, desired state configuration. This is the concept desired state desired state manager, DSC, sorry, desired state configuration is not just a Microsoft concept. It's a concept that's been there out in the industry. PowerShell with DSC helps you achieve it in the Microsoft stack. So moving into the next slide here, we're saying, so what is really desired state configuration? When I say desired state configuration, I mean what is PowerShell DSC? No surprise, PowerShell DSC is really an extension to PowerShell. It is not a new framework of any kind. You don't have to go off and learn a new language. What that means is the commandlets that you've been using for years, you continue using them in a declarative syntax now. That's the only change. Let the OS deal with the underpinning of figuring out how it needs to update the target. What it also does is it leverages the OS to help achieve the configuration you need. So in summary, as long as you can understand these 3 points, that's PowerShell DSC for you. We could just call it the end of module, but we won't because we have to get through some demos as well. And why is desired state configuration important? Well, desired state configuration is important because it prevents server configuration drift. You could just tell the server, this is the desired state I want you to have, and the server just manages its state so that it's always to that state. So for example, if you wanted to roll out an update of a Windows feature across all the servers you had, for Telnet, for example, that's a Windows feature. You don't need to program it keeping in mind what the base state of each of the servers is. You would just create a declarative script which says, your demand is that there's this Windows feature enabled. And as you roll that out, it's enabled across every server. What it also does is it takes away the configuration from the implementation. What that really means is if I'm trying to run a software that depends on a web server, then the logic to deploy the software is separate from me provisioning a web server or a server that has the web server role enabled on it. Now, this part of the equation I can easily tackle with a desired state script. So the software deployment doesn't need to worry about it. And that segregation of duties makes it really easy to administer, makes it really easy to manage and troubleshoot and recover from failures as well. Because, for example, if your server goes down, then standing up a new web server role using the automation you have is easier. But if that responsibility was partially shared by the script that was trying to deploy the software, then you run into all sorts of conflicts. It helps you think about continuous in deployment because it's a desired state. If you run the script once or twice, it's not going to change the state. It's just going to keep the current state. So you become brave about continuously rolling that script out again and again, and helps you think about the continuous deployment mode. A DSC script can be run on-prem, can be run in the cloud, can be run in other cloud platforms as well, and it would just work in the same way. So it's knowing one technology and being able to use it across cloud platforms. And topmost for me, it kind of helps you leverage your existing PowerShell scripts. It's not having to go and learn a new framework. It's just building on an existing framework. Now that we understand why PowerShell DSC is important and how it works, let's spend a little bit of time looking at the architecture within DSC. So the DSC, desired state configuration, has 2 modes. One is push, one is pull. Now, the names kind of define them quite well within themselves, but just to call out, a push mode is where you author a script and you push it to the server where you need the desired state configured. A pull is you author the script and send it to a central authority, and every node that needs that script will come to the central authority to get an update. And this model really scales because I only create the script once and I put it in the central authority, and then every node, and node's what it's called, right? The target machine connects to the central repository to pull the updates that it needs to make sure that it's aligned to the configuration that I had authored. Um, the pull can be set up. The pull server can be set up by yourself, but then again, we're moving into this brave world where we don't want to manage administration and automation tools ourselves, and that's where Azure Automation comes in handy, because Azure Automation hosts the DSC pull server for you, so you don't have to worry about setting up an HTTPS endpoint, load balancing it, fault tolerancing it. It's all built into the Azure Automation framework. Now, this slide is really just to take you through the workflow of how a pull server works. We kind of talked about it, but at a high level, this is the guts of how it works. And knowing this is useful because when things fail or they work as not so expected, then you at least have the inner knowledge of figuring out where the problem lies. So in this script here, I'm authoring that the telnet Windows feature be enabled. It's a configuration that I'm creating using PowerShell. Once I've authored this script, I will send it to the central server, which is called the pull server. What the pull server does is it compiles this script, this configuration script, into two key outputs. One is MOF and one is resource. Now MOF, if you're coming from a .NET programming language background, it's the IL. It's the intermediary language, which means MOF is not just a Microsoft solution. MOF is a solution that all operating systems understand. As long as you can produce MOF, you can run MOF on any framework, any tool, any platform. And that's exactly what the pull server is doing. It's compiling your configuration script into MOF file, and its dependencies are captured as resources. So all these nodes on the right that you see in the execution block have been registered with the pull server. So when they come to the pull server, they say, well, this is my current state. What is the target state? Let me validate. And if it finds that there's been a drift, then it will take the updated configuration from the pull server, i.e. the MOF file and the resources, give it to LCM, the local configuration manager on the OS, and the LCM will just queue a job for itself to figure out what the desired state is, what the current state is, and the kind of scripts it needs to create to bridge that gap. And that's really it. And that would just complete the whole workflow. Now, the question that I get asked a lot is, okay, well, you showed this DSC script. It looks pretty straightforward. Are there any best practices when authoring DSC scripts? When you start with DSC, you could just start creating basic scripts. But when you start to roll these scripts out at scale, you kind of need to think about best practices. Now, the great thing is that the PowerShell DSC GitHub repository, the open source GitHub repository, has had over 100 forks, an umpteen number of contributions from the open source community. And this is a great result of that. They have a common page now which talks about all the best practices that are available. So let me just quickly flip over and show you the page and talk about or mention briefly some of the best practices. So here's the DSC resources PowerShell GitHub repository. And on the best practices page, you can see it's been quite well categorized into what it relates to. So for example, avoid using hard-coded computer names. So if you're going to use a DSC script and it needs to be applied to multiple servers, then why not take a parameter as the input, which becomes the parameter to accept the computer name. So don't hard-code it. Avoid empty catch blocks. I've seen that a lot where people just want the script to run even when there's an exception, so they'll create an empty catch block. The problem with this is if there's a real problem or a failure that happens, where you kind of eat the exception, so you never know why it failed. And there are plenty of examples on other good practices, best practices that you can follow when authoring DSC scripts. So I hope you found the concept video on DSC useful. It's clear now why DSC is important, what it's built on, the evolution, and why it's set up to help you deliver DevOps better.